just for a picture. Greetings, just for a face to see. I'm Norman Snowden, retired civil engineer and developer of several Mykinda software programs. The subject program is Mykinda Traverse. It provides mathematical tools that a property surveyor, property owner, or contractor can use to meet basic highway engineering needs. Additional later videos demonstrate other Mykinda Traverse features. This video shows how to calculate earthwork roadway excavation from cross sections over a length of station distances. Excuse me. The amount of fill volume versus the amount of cut volume is shown for each station, including the net volume of either fill or cut. The accumulated cut and fill is also shown for each station. The cross sections can have various shapes for both ground slopes and road slopes. These calculations can be an easy way for a contractor to estimate the grading and haul costs for a proposed roadway or driveway. After viewing the video, if you have further interest in Mykinda Traverse, send me an email at duluth@msn.com. Subject, Mykinda Traverse. This video should also be available at mykinda.org at a later date. Thanks. We click on the Mykinda Traverse little icon, and we have to agree to abide by the rules for program use. And then we're user number 1. We click Mykinda Traverse. Let's expand this a little bit so the whole whole screen is shown. Okay. Now we're going to, I'll show you a plot of one of the, this is a special plot that will be discussed later, where you show a road is being widened for 6 feet and the slope is flattened. I didn't intend to start with this, but anyway. Now, you have to have, for excavation, you have to have records of the same name. In this case, we have 7 EXCA named records, starting at station 100, 200, and so forth on up to station 700. Let's take a look at station 200. In order to get the plot, we have to calculate it. There's a variety of other functions that on this in this program screen that we're not going to talk about to any extent tonight. We're waiting for this plot. There it is. We take a look at that, and we see that it's a cut section. Here's a 24-foot roadway with back slopes of 45 degrees, and then the ground is actually crowned in the middle a little bit. Shows the area and the total distance east and west, and the total north and south distance, station, and the traverse record number and the area. That's a cut section. And let's look at a fill section. That's say station 500. Click on calculate. We have to wait for it to calculate so we can see that. This is set up that you can enter distances and directions and plot the areas. And also, now it's finished, so we'll take a look at that. Now that's a fill section. The ground is still crowned, but it's below. It shows the area and shows the back slope, and the road is level. We could have this road sloped if we wanted to. But that's what this is doing, is calculating these cross sections. In this case, this area is 433 square feet. Let me go back. We can go down to station 7, and that's station 7, and ask it to, we'll go to this excavation and VC curve push button, and we get a message that really is definitions of particulars on these vertical curves, and also excuse me, other information. This is further definitions. Now it asks if we want to evaluate a vertical curve or calculate cut and fill volume. We do, so we click yes. Now this is a pre-calculation, but it shows the excavation record name, the cut volume, fill volume, the net volume, and the total volume. Let's calculate that again. It asks if we want a hard copy, which we do not. Then it shows the station number and the roadway elevation and the ground elevation of each station. It asks if we want to plot or just to calculate the volume. So we don't want to plot right now, so we'll say no. So that calculated the volume, and the same thing. Now let's go back and do a plot. It asks if we want a plot. We do, so we'll say yes. Now we see starts off at 0 with no cut or fill, and it goes into a cut. Shows the ground at each station and the road elevation at each station, and whether it's a cut or a fill. This is a long fill. Again, it shows the cut volume, the fill volume, net volume, and the total volume, and the name of the record. Now we can go home and let's take a look at how this is generated. We'll go to that one that has roadway sections. For a fill section, the road's on the top. It can be sloped, and you have to put in a fill slope, which is goes up. It's a 1 to 1. A 1 to 1 would be 45 degrees, and if you put in 0.5 here, you would have a flatter slope. This is the ground slope left and the ground slope right, the ground elevation, the road elevation, and the total width. And the fill section is similar, but we call this cut slope, but it's actually the same thing as a fill slope, and just a different name. It's a slope of 1 to 1 too. A 1 to 1 would be 45 degrees. And the ground slope left, it's 1, and it goes from 12 to 12, or usually a flat slope would be about a GSL of 1. Now you could have a -1 too, if you wanted to flip the slope of the ground. This shows the ground sloped. It's a cut section and a fill section. Over here is where we don't need we're not working with side hill right now, so we don't need a side hill width. We have a station number, the ground elevation, the road elevation, total road width, ground slope left, ground slope right, cut or fill slope, and road slope. And for a full road section, we calculate here. So let's click on calculate. It brings up the directions and the distances. And again, let's go ahead and calculate that. I think we've already looked at that particular cross section, but we'll do it again. This program will handle latitude and longitude also. If you put in an initial latitude and longitude, then you can calculate all the rest of the longitude and latitudes for different points. Well, that's through, so we'll look at that. So that's that same section that we looked at previously. But anyway, you can see that you have an option of different slopes on it. Let's go back to these roadway sections. This is really a diversified program. Now here, you could have a cut slope in the side of a hill. There's ground elevation and the roadway elevation and the cut slopes that you would put over here, and the slope of the road, and then you calculate that and run calculate, and you can get the area of it. You could also have a roadway on the side of a hill, a fill slope, and that's what this is. It's pretty simple, because all you need is, in these cases, is the road elevation and the ground elevation and the side hill width, whatever the roadway width is. Now, this is a good feature. In some cases, you might just want to flatten an existing roadway slope, which you can do with this section here. We call it calculate slope flatten and widen cross sections. This thin line shows what you would be doing if you widen the road. That would be the widen dimension, and they would put in a side hill. Rather than change nomenclature, I just used side hill width. You could have a 10-foot widening and a flattening of the slope. Let's see if we can run that again. We come down to that's a different name, but anyway, go back to road sections, and this side hill width here we've got is 6 feet. Ground elevation is 410, road elevation is 400. Don't need total road width now. And you put in the ground slope left, ground slope right, and the CS. And let's click on that. Now it's calculated these dimensions and distances, but to get in order to plot it, we have to calculate it. So we calculate. Here's an interesting feature. If you know the latitude, if you have a latitude and longitude of 2 different points, you can get the distance and the direction of those between those latitude and longitude points. It comes out in miles distance and azimuth direction, but it actually you can get it down to about the nearest couple of feet. Even it calculates to the nearest foot for that matter. Now let's look at that cross section again. There it is. The road is widened 6 feet and it's 10 feet. This road is, the ground slope is 10 feet above, and it gives you direction, the distance of each in the area. This is very same thing that we discussed. As I said, there are various functions that are involved here that we're not discussing that will be covered in a later video. I appreciate your interest in listening to this, and if you have any further interest in it, give me an email. Thanks.